Good morning, good afternoon, good evening, from whichever location you are viewing this video, from whichever location you are watching this video. Now, before I start this video, I would like to thank indiamentor.com because they regularly organize such kind of fundamental sessions. So I'm very thankful for them, because in today's world, where people are talking about cloud computing, people are talking about data science and data mining and artificial intelligence, somewhere, there should be equal focus on fundamentals, on data structures, on algorithms, on object-oriented programming, on SQL, right? And India Mentor is one of those organizations, who keep doing these kind of programs, where they focus on fundamentals. So I'm thankful for them, because to organize such kind of session, you need money, you need time, you need a lot of dedication, right? Second is, I would like to also thank questpond.com to make this happen, because they have organized the mics. I've used their studio, so I'm very thankful for them. So in this video, we will discuss about why do we need interfaces. So here is the agenda of this training. Okay, so let me not use that word training, because things like interfaces, abstract classes, object-oriented programming, there are a lot of these concepts, who have multi-perspective. So when a developer looks at a class, or if they look at an interface, or if they look at abstract classes, they see different perspective depending on their experience, depending on how they understand it, depending how they feel about the topic. So rather than saying this is a training video, let me say that this video is where I will express my perspective, my personal perspective about interfaces. And if you are syncing up with that perspective, then you can put down the comments below. And if you have your own perspective, as I've said, that when you talk about interfaces, every developer has his own perspective, right? Some people say that interfaces is a contract, and then some say that it is for multiple inheritance, and then some say this and that and abstraction and so on. So everybody has a different perspective of an interface. So rather than saying that this is a training video, I will say that in this video, I will express my personal experiences about interfaces. And then you can comment down in the YouTube that what do you think about these experiences. We can discuss and we can conclude interfaces in a better manner. So this is more of a perspective video rather than saying it's a training video, but still here is the agenda which I have. First thing I will discuss about that why understanding interfaces is so confusing. Why isn't it straightforward like understanding for loops and if conditions? Second, I will talk about the deep relationship between interfaces and contract, right? Third, I will talk about my experiences, when I look at contract. So I see contracts from two perspectives. One is there is an implicit contract, and one is there is an explicit contract. So I will also discuss about implicit and explicit contract. Also, I will discuss about the benefits of impact analysis and change management when we implement explicit contracts. Then I will clarify some statements, which people discuss about interfaces, like interfaces cannot be changed. Interfaces is for versioning. By using interface, we can implement abstraction. Interface is for multiple inheritance. So basically, I will discuss those topics and clarify them from the point of view of interfaces. So this is a 35 minutes of video. So let us start. Now, before we deep dive into interfaces, before we try to understand that why we need interfaces, let us first try to understand that why is understanding interfaces so confusing? Why is that developers keep discussing about interfaces and they come out with different conclusions in different times, right? If you see interfaces from the perspective of a developer, every developer looks interfaces from different perspective, because interfaces has multiple uses. Some developers, depending on their experience, depending on what they have learned, or depending on what they have understood, some developers can say that interfaces is for multiple inheritance. Some developers can say that interface is a contract. It helps you to do standardization. It helps you to apply abstraction. It is like a contract and so on. So basically, because of the multiple use of interfaces, every developer sees interfaces from his own perspective. Now, because of such kind of multi-use scenario, we never conclude what is the real benefit of an interface or what is the real use of an interface. So every developer is right in their own perspective and the conclusion never happens. When you have such kind of a scenario, to resolve this, we should try to hunt the root of that entity's existence. For example, when you talk about a mobile phone can have multiple uses. You can send an SMS, you can check an email, you can do a lot of things, right? Or do social networking and so on. But at the end of the day, the final use of a mobile is for speaking purpose. So even here, we should try to hunt that what is that root reason of interface's existence. So let us try to analyze that. So with all that definitions, which are floating around, and with all the discussions, whatever I had with my friends, the experiences, what I had in a project, what I understand is that interface is a contract. And the other things like, multiple inheritance, versioning, standardization, decoupling, enforcement, all these are byproduct of a contract. So the basic use of interface is that interface is a contract. So let us first try to understand what is the meaning of contract in the real world. And then we will see from the perspective of the software code. A contract in a real world or in an actual world is nothing but it is a legal binding between two entities. So a customer can have a contract with a supplier wherein the customer says that, yes, I'm going to pay you X amount of money for this product, and the supplier promises to deliver that product in the X amount of days. So a contract is a legal binding which two entities decide to follow, and if any one of them breaks it, then that transaction is not possible. Now let us try to understand from the source code perspective, from programming perspective, what exactly is a contract. So now in application development, it is very much normal that one part of the code can call the other part of the code. So if you look at developers designing mindset, they develop components in a modular way. So you can have an accounting component, you can have an invoicing component, and the invoicing component can make a call to the accounting component. So normally developers, when they do development, they create modules, and one module can call the other module. So you can have one module calling the other module. You can have a client calling a server code. You can have a UI consuming a component. So it is very much normal that to increase reusability or to do modular development, we normally have a situation where one part of the code calls the other part of the code. So for example, here you can see I have an UI. This is a console application. I can rename this. So here's a very simple situation where I have a user interface. This user interface is a console application, and this console application is consuming this maths component. So you can see that I have a caller and this is the callee, right? So we normally have a situation where one part of the code calls the other part of the code. Now, in order that this UI, which is consuming this maths component, has certain expectations. So he says that, okay, from the maths components, he has expectations like, the maths component should have methods like add, subtract, multiply, divide, and so on. So basically, the UI developer who is consuming the maths component, so for example, when the UI developer goes ahead and consumes the maths library, so I'm going to go and this is my UI code. So in this UI code, I'm going to go and create an object of the maths library. Now this caller, this client, this UI has certain expectations. He says that, see, I need to find the add method, and the add method should have two parameters like num1 and num2, or I need to find the subtract method, right? So if he does not find this method, if for some reason this maths component does not have a subtract method, right, then this call is not possible. So you will see a red sign over here saying that the subtract method has not been found. So basically now here there is a contract. There is a contract between the UI and the maths component. There are some expectations. The UI says that I need to find these methods or else this transaction is not possible. So when you talk about application development or when you talk about programming, there is a contract between a caller and a callee. There is a contract between a client and a server. There are certain expectations between the UI and the component that I need to find these methods. If these methods are not available, then I won't be able to run the application. So a contract in a programming world means that you have one code calling the other code, and they expect certain methods, they expect certain parameters, they expect certain data types. And if those data types are not found, then you end up with an error, or that call is not possible. So this is a contract in a programming world. So point number one, which I want to stress here, is that contracts in application development is always there by default. So whenever one part of the code makes a call to the other part of the code, there is an implicit contract. There is an unsaid contract. There are certain expectations in order that the call should be successful. So one thing which you have to remove from your mind is that contracts are only possible via interfaces. No, 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 no. Contracts are everywhere. Whenever you make a call from one part of the code to the other part of the code, there is an unsaid contract. There are certain expectations of the caller and the callee, of the client and the server, right? So first thing is, there is something called as an implicit contract, right, between caller and the callee, right? So for example, over here now, there is a contract, or there is an implicit contract wherein the UI is expecting the subtract method, and if it does not get the subtract method, the application does not compile. This transaction is not possible. So point number one, there is always a contract, irrespective you have an interface or you do not have an interface. Now in this particular situation, this particular scenario, the caller is referencing the callee directly. So in other words, this user interface is referencing the maths component. That's why there is an implicit contract. But now let us say for some reason, for numerous reasons, I will say, there are situations wherein the caller is not aware of the callee. He knows what call to make, but he is not in direct contact with the callee. For example, situation number one, the architect of the project decides that I want to decouple this user interface from the maths component, right? So that when the maths component changes, the user interface does not have to compile. So this is situation number one, wherein the architect decides that the UI should be decoupled from the component. The other situation can be where the caller and callee is not directly connected, is because of your physical deployment. So you can have the caller deployed in one machine and the callee is deployed on a server, right? And they do not have any direct contact with each other. The only call must be they are making is through some protocol like HTTP or TCP. So there are a lot of situations, where suddenly the caller and callee are not referencing each other directly, right? So for example, now let us take a simple situation wherein the architect decides that this UI should not reference the maths component directly, so that we have a decoupled architecture. So what he does is he probably goes ahead and puts a layer like factory or some kind of an intermediate layer, right? So let us say now, as an architect, I decide that the UI should not reference the maths component directly. So I go ahead here and create a factory. In case you are new to factory pattern, I would suggest to go and look at the factory pattern videos. But for now, you can just assume that this factory layer will help us to decouple the user interface from the maths component, right? So I'll say this is factory layer. So this factory layer references the maths component, right? So this is factory maths. We can make this as static. So using maths component, right? So now this factory layer says that, okay, I will go and expose out the maths component, right? So he says, here is it, maths component, or I'll say create maths component, right? And he returns a new maths library. Okay, everything has to be static, fine. In static classes, everything has to be static. Now you can see that I'm using a dynamic keyword here. I'll come to this dynamic keyword later on. This dynamic keyword is a .NET keyword, which says that on the runtime, I will decide what is the component, what are the methods. So in case you're new to dynamic keyword, I would suggest to go and see this video in Correspond VD where I've explained what exactly is a dynamic keyword, right? So for now, you can leave this dynamic keyword as it is. But what here I'm trying to do is, I have a factory maths, and this factory maths says that, if you want to reference the maths component, please refer via me, so that when the maths component changes, the user interface does not have to change. Now look at this situation. In this situation, the caller and the callee. So now here, this UI will refer the factory layer, right? It will refer the factory layer. So factory layer, right? And I will say here now, rather than I creating the object, I will say that the factory layer, the factory maths layer will create the maths object for me, right? And then I will make a call to subtract methods. I will make a call to add method and so on. Now, if you see this situation out here, in this situation, the caller, that means the UI, is not referencing, you can see here, he is not referencing the maths component, but he is referencing via some layer. So now, in application development, we can have numerous such kind of scenarios, wherein the caller is not referencing the callee code directly, right? So now if you see at this moment, this code will run, right? So this dynamic keyword, what this dynamic keyword does is, this dynamic keyword says that I will decide on runtime. On runtime, I will decide, is the subtract method existing and is the add method existing? So if I make a call here, so let me just make a call here. So I'm going to go and run this code. So now the factory maths will create the object of the maths component. So there it is. He is creating the object of the maths component, and then the subtract method is decided on runtime. So on runtime, it decided, yes, this is the subtract method, and you can see that this is the add method, right? So this is other situation wherein the caller and callee are not connected directly, and still we expect that the call should happen, right? Now over here, for some reason, let us say the maths component developer, decides that this add method should be add numbers. So the person who has created the component, right, the callee code developer decides, I'm going to go and change the code of it. And if I compile this project, I will not get any kind of errors, because the caller and the callee are not connected directly, right? So when I rebuild this solution here, you can see that I'm getting rebuild all succeeded. So there are no errors, right? But now what will happen is during the runtime, my program will crash because, so if you see here now, during the runtime, when I try to run this, I'm going to go and just run this, I will get an error saying that this add method does not exist. Now we are in a situation wherein the maths component has changed, and the clients who are consuming the maths component are not made aware that the change has happened in the maths component. And this can be catastrophic. Why? Because assume that this maths component is consumed by a lot of clients. It is consumed in a lot of places, right? So all the calls of those clients will now start crashing, isn't it? So now we need some kind of an alert system. So during the development time itself, I need an alert system wherein someone will say that, yes, if I go and change something out here, it's going to affect here, 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 and everywhere, right? So I need some kind of an alert system. That's where we need explicit contract. Now this is a situation wherein the caller and the callee are not connected directly, and we need an explicit contract. That means we need an interface. So now over here, let us go ahead and add an interface. So let me add a new class library. And so I'll say this is now iMaths, right? And in this iMaths, so this is the iMaths interface, right? So this interface will have a method called as add and it will have num1 and num2. So normally interfaces only have definitions, right? It does not have any kind of code as such. It is just a signature. It is just a structure. Okay. So here it is. This is an interface. So I'll use the interface keyword. So this is int add and this is int subtract, right? So now this is a contract, an explicit contract. We have written down the interface and we say to both to the caller and the callee, saying that both of you guys have to reference this interface. If any one of you change it, if any one of you do not follow it, then this call is not possible, right? So if you see here now, so first thing is, let us go to the maths component. First, the maths component goes and adheres to the interface. So I'm going to go and reference the maths component, reference the interface. And over here, I will say using imaths, right? So now this maths library, we will go and implement the maths interface, right? So you can see now this maths interface has add and subtract, and both of them are implemented. In case if, let us say, the component creator goes and gives some different name out here, then this interface will start complaining and will say that, see, you have not implemented the add method. So you can see that he made it add numbers, and the interface signals him that if you do not make this as an add method, then the other party who is calling you will have problems, right? So if I now go and change it to exactly add, it does not complain, right? In the same way, even the client will now use this interface to make a call. So here also the client will now use the imaths. You can still see that I am not referencing the component directly. My user interface is not referencing the component directly. It is just referencing an interface, right? So now here also, so here now, rather than saying this is dynamic, I can say now this is imaths, right? So even in the factory, rather than making it too dynamic, I can say this is imaths. So even in the factory layer, I will refer the interfaces. So I'm going to go and refer interfaces, because dynamic is too broad, right? So dynamic should be used in situation where it is really runtime. So imaths, so imaths, right? Now if you see the situation, so here I have that is imaths, imaths interface, I'm sorry. imaths is the namespace and this is the interface, imaths interface. Now you can see the interface has created an explicit contract. He says to the UI layer that you will get an add and a subtract from this. And he says to the maths component developer that you need to follow this. If you do not follow this, then there will be a problem. So now this call will be successful again. So if you see now, this should really work. So if I run this, so there it is. It goes and it calls the subtract method, right? So now if the maths component developer for some reason goes and says this is subtract, something like this, he gets an alert here. He gets an alert and he says that, see, if you change this, this is going to impact in a lot of places. Are you sure about it? Right? So in other words, now for some reason, if somebody goes and fiddles around with this, if he says, oh, this has to be now subtract like this, then you will suddenly get an alert throughout your system saying that, okay, it crashes here, it crashes now here, and it crashes there, and it crashes there. So if you look at the first situation, where there was no explicit contract, there was no alert system. So I did not have any kind of impact analysis of what will happen if I change that add method or the subtract method. But now in this case, wherein I have an interface at place, I have an alert system I have a way of impact analysis, where it says that, see, if you change here, it's going to affect in these places. Are you sure about it? Right? So interfaces are contract. Interfaces helps you to implement impact analysis, in case if you change a method, in which places it will affect. So what I feel personally is that interfaces should be used in places, wherein the caller and callee are not connected to each other directly. In rest of the situation, I feel that interfaces are extra work, right? So for example, if you look at the first situation where the caller was connected direct with the callee and we were okay with it, right? We were okay with that kind of architecture. I won't put an interface. But in this situation, wherein the caller is not aware of the callee, and if anything happens bad, then during the runtime, I will get errors. During the runtime, my project will crash. So in this kind of situation, an interface is needed. An alert system is needed. An impact analysis is needed. And one more very important rule, which you will see from every developer about interface, is that once the interface is decided, it should not be changed. So once you decide that the method name is add, the method name is sub, right? You should not change it, because if you change it, it's going to affect a lot of places. But now here it is. Remember, there is one big confusion about when the interfaces should not be changed. Okay, so there is no golden rule as such. But when you are doing development, when your project is just getting developed, it is okay to change the interface. Means, for example, I am developing the project, it is still not live, it is still not in production. So I go and change this add to add two numbers. I can change this subtract to subtract two numbers, because I'm developing the product still, right? But once it goes in deployment, after that, the interfaces should not be changed, because once it is in deployment, once it is in production, then you need to be careful that if you change these interfaces, in which places the impact analysis can happen. So let me correct that statement, because that statement is too vague. Interfaces should not be changed once your application code goes in production. I again repeat, interfaces should not be changed once your application code goes in production. The other place, where I find interfaces to be extremely useful is to create abstractions, to create customized abstractions. What is abstraction in object-oriented programming? Abstraction means show only what is necessary. So as per the level of the client, as per the maturity of the consumer, of the caller, you only show him methods which are important for him, right? For example, now let us say that this maths component what you have created has basic maths and advanced maths. So some developers want to consume the basic maths and some developers want to consume the advanced maths. Now the developers who are consuming your basic maths component does not want to get into problems of advanced maths. So what you can do over here is you can go and you can create multiple interfaces. This is where developers say that interfaces have multiple inheritance, right? So they say it unknowingly, but the reason of multiple inheritance is to create different abstractions, customized abstractions. So now what I will do is I'll say, okay, so I have two kind of consumers. One consumer who is just interested in the basic maths, and there's the other consumer who is interested in advanced maths, right? So I can go and I can create an interface here saying I advanced maths, and I will say that this I advanced maths will have everything about I maths. So I can say that this I advanced maths will have everything about I maths, that is this basic maths, but he will have something extra as well here. So he will have probably a function which will help us to do log, to do logarithmic calculations, right? Or he will have methods here, which says that, okay, how do I go and calculate the radius of a circle, right? And so on. So basically this I advanced maths has some more mathematical functions, adding to the basic functions, right? So now what I can do over here is I can go here and I can say, so one is that I can go and inherit from this, right? So let's inherit from this. Okay, so now I can go here and say to my iMaths interface that please go and inherit this iMaths, I advanced maths, right? and also implement the rest of the methods. So let's go ahead and implement the rest of the methods. Advanced maths, yeah, that's so bad. Implement interfaces, yeah, that's what I want. So you can see that I have implemented log and radius. Now what will happen is, so when I look to my maths, so also from the factory now you have to return iMaths advanced. So iMaths advanced, iMaths, why don't I see advanced maths, yeah. So now what will happen over here is, now look at it. So when a client sees via iMaths interface, he will only get add and subtract, show only what is necessary. But if he creates the advanced maths, so if he goes and creates the advanced maths reference, right, from this he will see everything. He will see the add also, he will see the subtract also, he will see the log and the radius also. So basically, again, the other important use of interfaces, irrespective the caller and the callee are not connected directly or they are connected directly, is I've seen developers using interfaces to create beautiful abstractions. So they create multiple interfaces and then they say that, okay, so if you see via this interface, you will see only these methods. And if you see via this interface, you will see these methods. So again, one of the other benefit of using interfaces, or the compelling reason of using interfaces, is that it helps you to define a very basic structure without any code, and then it helps you to implement abstractions of different complexity. Also, I would like to speak 10 minutes on multiple inheritance and interfaces, because if you see, one of the things developers say is that the biggest use of interface is multiple inheritance. I don't know from where that statement comes in, but I've seen that developers, the time you say what is the use of interface, I've seen 20 to 30% developers saying that interface is for multiple inheritance. But my personal feeling here is that multiple inheritance of interfaces is a phenomena which can happen once you go in production. So when I start designing a project, I do not think that I will have multiple inheritance at the start. Okay, means what? For example, now let's say that this application goes in production. So you have an iMaths interface, the basic one, you have an advanced maths, it is happily running. You respect the laws of the interface, you never go and change these interfaces once it goes in production. You never go and remove these methods, right? Because they are all over the place. And if you want to remove them, then you need to be aware of the impact analysis. So let us say that this application goes in production, everything is good, right? Now someone comes and says that I want to have a multiply method. So you can see here that we have add, we have subtract, but we do not have multiply and divide, let's assume. Now, I do not want to go and change this interface because it will affect a lot of places. I do not want to go and change this one because that is also used in a lot of places. So what I do is that I end up creating a new interface. So I say that whatever is my existing code, let us not touch it. Let us not touch it. Let us create a new interface here. So I'll say that this is a new interface. And I'll say public interface iMaths multiply and divide, or I'll say iMaths maths 2, right? This iMaths 2 will have multiply and divide. You can see that the methods, I've just kept it as void for simplicity. Definitely, divide and multiply should have some parameters, but I've just kept it as it is. And then what I will do is I will go now to the maths class and I will say here that this one will implement iAdvanced Maths and it will also implement iMaths 2. You can see now there are two interfaces, multiple inheritance, what you say, right? I've implemented. So this also we will say implement this interface. So in other words, multiple inheritance, we will only do when you say that you do not want to touch the existing interface and you want to go and add new methods. So in that case, rather than going and changing the existing contract, because if you change the existing contract, it's going to go and break in a lot of places, right? So you can see over here now we are using multiple inheritance. So multiple inheritance is a byproduct of contract. Abstraction is a byproduct of a contract, right? The main use of interface is that it is a contract, and all the other things like multiple inheritance and abstraction and whatever we have discussed, right, is a byproduct. So let us summarize, what we have learned about interfaces in this video. So let's summarize what we have learned. First thing, we will use an interface, or I will use an interface to define explicit contract where caller and callee are decoupled, or they do not have direct references, right? And the benefit of this is we have a great impact analysis in the build time, we have change detection in the build time, and because of the impact analysis and change detection in the build time, in the runtime we will have less problems, right? So this is one of the biggest use of interface, or I'll say, at least from my perspective, this is the only use of interface. The other uses like abstraction, which we discussed, show only what is necessary, is a byproduct. So the abstraction which we discussed, show only what is necessary, is more of a byproduct. Third one, multiple inheritance of interfaces will happen only when you go live in production, wherein you have gone live and then you do not want to change the interface, because if you change that interface, it's going to affect in a lot of places. So you end up creating a new interface and you end up doing multiple inheritance. So here is my take personally on interfaces. One of the things which I've seen in the IT industry is that people say that for every class you create, you should create an interface. I do not agree to that, because I feel that that's an extra work which we add to. So if you have a class, that class is never going to change once you create it. Once you go to production, you do not expect too many changes in that. Why would you like to create an interface in between? If you have a class, which is running direct, you are referencing it directly, right? And you are not creating a decoupled architecture. Why do you need an interface in between, right? So my feeling is that the time I go into a client server environment, the time I go into a kind of environment, wherein my client and my server are not connected with each other, and I just want to ensure that I do great impact analysis, right? I will use an interface. So this video is not a training video, as I've said, when I started this video. This video is to just create a platform for discussion. So if you have any comments on this video, I would suggest to go to the below YouTube link, YouTube comments box, and put down your comments. What do you think about interfaces? Thank you very much.